welcome to another interesting lesson. In today's lesson, we want to solve this nice expression. So what is the value of x in this interesting question? So let's solve for x. What we are going to do in this lesson is to use a normal familiar approach to solve for x and another equivalent form which is not familiar to most people. So stick to the end to learn about this. Let's begin. Solution. What we need to do first is to have our question 10 to the power of x equal to 25. So we need to take the log of both sides. Log 10 to the power of x equal to log 25. So we can express this as log 10 to the power of x equal to log 25. Then we simplify this as 5 to the power of 2. Then we have from both sides the power of x and power of 2. Then that can be bring to what? To the base using one of the identity of log. So we now have the next expression to be x log 10 equal to 2 log 5. Now from here we can divide both sides by log 10. So we divide this by log 10 and we divide this by log 10 so that this log 10 can cancel out with this log 10, and we will now be left with x isolated at the left hand side. So we have x will now be equal to 2 log 5 over log 10. In a simpler form, using the log identity, we can express the s to be equal to x will now be 2 log 5 with the base of 10. So this will be our value of x, and this approach is more familiar to most people, but an equivalent form of this approach to this is to say, if we have log 10 to the base of 10 to be equal to 1, we can easily say that this log 10 base 10 can be written as log 2 multiplied by 5 to base 10 can also be written as equal to 1. Now considering the log identity as well, when we have log a multiplied by b is expressed as log a plus log b. So we can use this identity to simplify this left hand side, and we can write it as log base 10 2 plus log base 10 5, and that's as well equal to 1. Okay, now we can move this side, this log 2 base 10 to the right hand side, and that becomes negative. So we now have, and that will isolate log 5 base 10, and that will become log 5 base 10 will now be equal to 1 minus log 2 base 10. So this expression we derive in the value of x in the previous value of x. So log 5 base 10 can be seen from our previous value of x over here. So where we have this, we can now substitute this into that, which implies x that we got previously will now be equal to 2 into 1 minus log 2 base 10. So we can also expand this bracket and we have x equal to 2 minus multiply by this 2 log 2 base 10. So we can have this as our value of x as well, which is equivalent to the previous one. So we now have that x can either be this, or x can also be written as 2 log 5 base of 10. So these are the two values of x using this approach. So another thing we are going to learn from this question is that we can use another shortcut method. A shortcut method, which is method 2, is to using this shortcut method. From our question, we have 10 to the power of x equal to 25. So we can simplify the right hand side as 10 to the power of x equal to 5 to the power of 2. In another way, we can also say 10 to the power of x is equal to 10 over 2 is given by 5. Then we can now square this. Okay, we can now square this. Simply, this also means that we can write this as equal to, we multiply the square with what we have in the bracket. So we have 10 to the power of 2 over 2 to the power of 2. Okay, we can rewrite this as well. Since our expression can be written as this, then we can now take log of this expression of both sides. We now say log 10 to the power of x equal to log 10 to the power of 2 over 2 to the power of 2. Okay, now here we can also rewrite this in the form of where we have log a divided by b can be written as log a minus log b. So using this to simplify this right hand side, we can now put this in this form. So for the left hand side, we can also bring x down to the base. So we have x log 10 will be equal to log 10 to the power of 2 minus log 2 to the power of 2. So from here, we can also use our normal approach, bringing all this power down to the base as well. So we have x log 10 equal to 2 log 10 minus 2 log 2. Okay, 2 log 2. Now here we can isolate x by dividing both sides by log 10. So we have divide by log 10. We also divide this by log 10. Now this log 10, we go with this log 10, and our left hand side will be isolated with ordinary x. Now from the right hand side, we can separate this or rewrite this as 2 log 10 over log 10 minus 2 log 2 over log 10. So over here, this can cancel out with this as well, and we are left with x will be equal to 2 minus the whole of this, which is given as 2 log 2 over log 10. So simplifying this can as well be written as x will be equal to 2 minus 2 log 2 then base of 10. and this will be our x using shortcut method. Okay, now we can as well verify our value of x using the two various ways, just as we got the value of x. So verifying our x using this value of x and also using this value of x, the previous one. So verification. So at x equal to 2 log 5 base of 10. So let's substitute and let's verify the value of x. 10 to the power of x equal to 25. Inserting this value of x, which is the first value we get for the first method. So we have 10 to the power of this value, 2 to the power of log 5 base 10 is it equal to 25. Okay, now we have bringing this 2 to the power of 5. We have 10 to the power of log 5 base 10 will now be to the power of 2. Would that be equal to 25? So over here there is an identity which implies a base a to the power of log base, which is written as b. So using this identity, we can use it to express this left hand side. So this 5 to the power of 2 is representing b over here. Okay, so we now have from our left hand side 5 to the power of 2 will now be equal to 25. Multiplying 5 twice is what 5 to the power of 2 means. 5 multiplied by 5. Okay, and that is equal to 25, which verify the left hand side and the right hand side equal to each other. So this is using the value of x which we got from the first approach. Then the value of x at x equal to 2 minus 2 log 2 base of 10. So we can also verify this. So from our question, 10 to the power of x equal to 25. Substituting this value of x, we now have 10 to the power of 2 minus 2 log 2 base of 10 will now be equal to 25. So we can split this. Splitting this, that will now become 10 to the power of 2 multiplied by 10 to the power of minus 2 log 2 base of 10. Would that be equal to 25? Our 10 to the power of 2, which is given as 100, can also be multiplied. So from this side of the expression, whenever we have a negative power, it can be written as 1 over that very expression. So that's what I mean is this. If we have a to the power of minus 1, we can write it as 1 over a. So a here is this 10, base 10, while the minus 1 is representing the whole of this expression. We can now put this as 1 over 10 to the power of 2 log base 10 2. Will that be equal to 25? So now we have 100 will now be multiplied with this 1. We now have over 10 to the power of 2 log base 10 2. Will that be equal to 25? Okay, from here, from the denominator, we have that 100 over these 2 will be moved to the power of 2 over here. So we now have 10 log base 10 2 to the power of 2. Would that be equal to 25? Okay, now considering our earlier identity which we told us of base a to the power of log base a b, which is written as b, will now be used to simplify the denominator over here. So using this identity, we can now write the next step as 100 over 2 to the power of 2. Will that be equal to 25? So 2 to the power of 2 is given as 4, and we have 100 over 4. Will that be equal to 25? So dividing 4 with 100, that means 100 divided by 4 is given as 25, which is equal to 25. Means the left hand side is equal to the right hand side. Proof that our value of x, both value of x that we got from both approach are correct. Okay, mean that our value of x, these two value of x are correct value of x for this expression. Thanks for watching. If you like this video, please subscribe to this channel, turn on notification bell, and share the video to your loved ones that are in need of this knowledge, and we'll meet in another interesting lesson. Thanks and bye for now.